Good day to everyone. So good to see so many people joining Gulf of Finland Science Days. My name is Jyri Tirroniemi, and I work as a researcher at the Finnish Environment Institute, and more specifically in Marine Center. But today I'm going to talk a little bit about my thesis, my master thesis, which topic was microplastics in northern Baltic Sea bottom sediments. And as a supervisors, I had Outi Setälä and Maiju Lehtiniemi also from Syke. And I have divided my presentation into three main parts. First, the aims, then the study itself, and then the results. So my aims, I had two carrying main themes. First of all, I wanted to know how microplastic concentration in coastal soft bottom sediments. And I had two set of samples. I had 7 samples from locations close to the 6 coastal cities. So from all the way from Vaasa to Kotka. But I also had 7 samples from Pojo Bay, which is marked with the yellow circles. And the Pojo Bay is a semi-enclosed bay in southern Finland, close to Helsinki University's Tvärminen Zoological Station, so you may be familiar with that one. And as a second main carrying theme, I had testing and developing methods for monitoring. And like many of us know, MSFD obliges member countries to monitor state of the seas, and for wanted to test how to best to monitor 2 sediment samplers. And I tested the extraction process of microplastics. Size had an effect on results, and I then tried to how to detect, measure, and quantify microplastics. And here are 2 pictures of the sediment sampler. So on the left, you can see the Gemax coral sampler, and in the center picture, you see petit bonar crab. So from all the sample locations, I had the petit bonar crab, and from 3 locations in Pojo Bay, I had also the Gemax coral samples. And on the right side picture, you can see the freeze drying unit we used for drying the sediments. Before this, we tried to use oven in 50 degrees to dry our sediment samples, but soft sediments tend to solidify into hard as stone, and it was really hard to work with those samples. So thankfully, we found the freeze drying unit for treating these samples. Next, a little bit about the treatment and analysis. So as a first phase, we did the drying, and then we went to with the density separation with the sediment microplastic isolation unit. And this is the unit that Rachel Kopok et al. Described first. And like the density fluid, add the sediment into the tube, and you let it settle for overnight usually. Then you close the valve, and then you can filter the top part of the tube into the filter. And on the 2 topmost pictures, you can see 2 sediment samples. And you can see that there is quite a difference between the sediment locations. So the one on the left has a lot of plant residue. It was quite horrific to see at the first time. And on the right side, you see a sediment which was more finer, sandy sediment. And because the sediment samples varied so greatly, we had to use some treatments to get the microplastics out. So we used enzymatic treatment with cellulose and chitinase. And after that, we added hydrogen peroxide to get rid of some of the organic material. And after that, we had a second density separation to get remaining sand dense. So that you can see on the right bottom picture. For the analysis, the samples were stained with Nile red in acetone, and I used about 2 milliliters per sample. I also tried other concentrations than 0.1 milligrams per milliliter, and other solvents like hexane. But according to my per milliliter test, this concentration and this solvent had the best fluorescent of microplastics and least fluorescent of background fluorescent. The photographs were taken with Leica fluorescent microscope, and altogether nine separated pictures per filter were taken and then stitched together with the computer software. And the analysis itself were done on Fiji software, which is open source and widely used in research world. And the script was loosely based on Ernie Cassola's script, but I had to modify it quite a bit to work with my samples. And then I also, as a precaution, I took a selection of particles and analyzed those with the FDR just to see how much of the fluorescent particles were actually plastics. And then on to the results. Here is a picture of one of my filters, and you can see on the right side, you can see zoomed pictures of the smaller windows on the center. And you can see also, if you are really keen eyes, you can see that there's the outline made by the Fiji software. So you can get an idea how the analysis worked on these samples. A bit more about the results. This is the first main finding, I think. So the smallest size fraction, so from 25 to 50 micrometer, had significantly more microplastic particles than the four biggest size fractions. And this should be taken into account when selecting the threshold you're aiming for, so the lower threshold. And especially when you're comparing between the results between studies, since the lower threshold usually equals to more plastics. And this is also important when you're selecting the filter you're gonna filter your samples into. And actually, 80% of the particles found were under 100 micrometer in diameter. And this has been described in other papers as well. For example, Have et al. Found out that 95% of the plastics they found in their study was under 100 micrometers in diameter. Yes. And the second main result was that there was a high spatial variation. On the map, you can see Poyo Bay, I described in the first slide, and the samples are located. The sample locations are marked with the yellow circle. City of Tammisaari is in the middle, which is marked with the gray color. And there's two rivers flowing into Poyo Bay from the north, and they flow in close to the sample location named Pohja, which is the northernmost part. And other aspect I want to mention is the deepest location, which is in Syvänne, where we also had a sample location in the middle part of the Poyo Bay. And Tammisaari location, so the sample location closest to Tammisaari city, differed significantly from four other locations within Poyo Bay, marked with the star. And what I think is especially interesting is that even the second closest location, named Stadsfjärden, had rather low concentration of microplastics compared to Tammisaari, even though there was a bit more than 2 kilometers between those samples, and they're both rather close to the city of Tammisaari. And other locations with higher concentrations were Pohja, so the rivermouth station, and Syvänne, which was the deepest location. And even between Pohja, the rivermouth station, and the next station from it, so Sturön, there was quite a high variation in concentration between these two sample locations, even though they are somewhat 2 kilometers away from each other. I think it's very interesting. So there is a lot of variation in microplastic number within Pohja Bay. But there is also high variation between all the sample locations, so including the coastal stations. So in this graph on the vertical axis, you can see the particles, microplastic particles per kilogram of dry sediment. And on the horizontal axis, you can see the sample locations. On the left are the Pohja Bay samples you already saw on the last slide. But on the right side, there are the coastal stations, which I didn't show you before. And as you can see, there was a high variation even in coastal station as well. So what struck your eye probably is that the Porvoo has the highest concentration, almost 22,000 microplastics per kilogram of dry sediment. Sorry, but also that sample location close to Kotka and Vaasa had really low concentrations of microplastics. So, and to give you an idea how these compare to other studies, for example, Outi Setälä, I mentioned before, they made a study in Norway, close to the city of Bergen, and they had 4 sample locations close to the wastewater treatment plants, and they found concentration varying from 12,000 to 200,000 particles per kilogram of dry sediment. So quite a high numbers compared to my 22,000 particles per kilogram. But then you have to remember that their threshold was lower. The lower threshold was 11 micrometers when I had 20 micrometers. So this might be one of the reasons why there was a high variation between the studies. And then we of course have some studies from the Baltic Sea as well. From the southern Baltic Sea, Esiokova et al. From 2020, they made a study where they had 53 sample locations, and they found concentration varying from 100 to 10,000 particles per kilogram of dry sediment. But yet again, here you have to remember that their threshold was a bit higher than mine. It was 200 micrometers, I think, or yes, I think 200 micrometers. So you cannot directly compare these results, but you get an idea of the concentrations in other studies. And as a summary, these were among the first sediment results from the Northern Baltic Sea. I had high microplastic concentrations. Number of microplastic varied greatly, even very small areas. But I think more samples is needed for holistic assessment, and that the smaller microplastics are more abundant than larger ones. And these results were useful for developing monitoring. And with that, I want to thank you for your attention.
Okay, thank you, Jyri. So do we have questions? We have time for one question. Okay.
Oh, thank you for your presentation. I see that microplastic concentrations in your study are quite high. So my question is, do you prepare some blank samples to control the external contamination? And if yes, then how do you treat them?
Yes, we had control samples. And yes, those controls have been taken out from the results. And then we also made the recovery samples to see how much of the plastics actually go through the for the sample process. So we had both controls and recoveries.